So hello friends, Shivansh this side, and today we are on part 3 of the video in which we are solving some integrals from, oh my god, my laptop, in which we are solving some questions and precisely some integrals from this book of Colin Eon Valian, Almost Impossible Integrals, Sums and Series, and this is third part. So basically, someone was asking that why did you started your questions from question number 3? So let me tell you that question number 1 and 2 were quite easy, but like this was the very easy question number 2. So that's why I started from question number 3, because they were seriously very tough, and first time when I saw them I seriously felt that I won't be able to do them. And same is another type of question. Okay, so basically this is like whenever I shoot video I don't even solve them beforehand, so these are the first time I'm solving these questions, so that's why it takes a lot of time. And moreover, I don't know what digamma function is. Like I know I just know its definition, and that too I was just studying right now after seeing the question. So okay, so in this video we would be first of all trying to understand what digamma is, and also I forgot what tan h is, basically hyperbolic tangent. So we would see all of them. Let's begin the video. You may skip at least next 15 seconds. Okay, don't skip. So let's begin. First of all, why not let me solve this integral without using anything, because if you are being following my channel from previous 2-3 weeks, I have put a video which was somewhat like this. Of course, then in denominator it was e to the power x something. Basically I'm talking about the video in which we were deriving the most beautiful equation of the world. Sorry, integral. So basically 1 by 1 plus x is nothing, like the range is from 0 to 1, so we can write that it's nothing but 1 minus x plus x square dot dot dot. So this integral simply reduces to a sum. And what is that sum? This is basically x to the power s minus 1 plus r sigma from r is 0 to infinity minus 1 to the power r, right? And integral from 0 to 1, simply plus 1 by s plus r minus 1 to the power r by s plus r, and its sigma from r is 0 to infinity is the answer. But wait, okay, this is the answer, but wait, why can't they do everything simply? Why do I have to introduce this polygamma function? This answer seems to be pretty well good. Now let's try to understand what polygamma means, and sorry, not polygamma, it's digamma, and what we have to do regarding that. Like basically I can even do, if I am not able to understand what polygamma is, I would try that. I would leave this video here only like not the video but the answer here only, and then I go on to second part. So this is our answer. And this technique we have been using almost in every video, that we're writing 1 by 1 plus x is sum of GP. So I think this video should have something new. Anyways, basically we need it in sigma form. And you know what, like my processor, yeah. So basically if I put r as 0, it's basically 1 by s minus 1 by s plus 1 plus 1 by s plus 2 minus 1 by s plus 3. So basically if I put s0, then I'm simply getting ln2, and that is even justified. Whatever gamma is, it's justified, right? Okay, let's first of all understand what digamma is. So digamma is basically logarithmic derivative of gamma function, something like this, gamma dash by gamma. Okay, and it's related to gamma function using this thing. Is it sort of our relevance? And we have an interesting thing with this as well. Seriously, I'm getting nothing related to thing we have done. Oh no, yes, we got something. Problem is that we are having, like, this series does not have all the coefficients we need. Okay, next time in my life I won't come up with a thing which I even don't know myself. It's pretty sad. If I subtract them both, then basically I have one formula of gamma at precisely this thing. And does it help? Does it help? I don't know. Gamma 1 plus s plus 2 is gamma n plus half. It's something like this, minus n minus half. Okay, let's see. Let's first of all try to simplify this thing. Can we even simplify it? It's basically, if I take 1 by s common, 1 minus s out, 1 plus 1 by s plus 1 by 1 plus 2 by s plus 1 plus 1 3 by s. I seriously don't know. The only thing I know that I've solved this sum. Okay. I precisely don't know what digamma function is, so not my mistake. Anyways, let's solve this one as well. As far I can remember, 10hx is. So what do you think? Like if anyone of you can comment that it's good that I've gone live without knowing anything. Yup, we have written it correct. So this is a easier integral if we see in terms of just without knowing anything kind of thing. E to the power 2x minus 1 by e to the power 2x plus 1 e to the power minus sx, putting basically sx as t first of all. Like I'm telling you only because this question is seriously nothing and I'm not feeling even good while making this video because I seriously don't know thing I'm trying to say. No, it's still a good question. It's e to the power putting simply e to the power minus x as t, then let's see, then it would be something kind of this. Somehow I'm getting that feeling that this question is nothing, but let's see. I'm putting e to the power minus e to the power x as t simply, then e to the power x dx is dt, and what is dx is basically dt into e to the power minus x, that is 1 by t. And what is this? This is basically 1 by t to the power s. So integral t square minus 1 by t to the power s plus 1 t square plus 1. Well, it's a good question, I guess. Not that much simpler that we are thinking. Now what? Putting t is equals to 10 of z, then it's dt. So dt is sec square z, that is 1 by 1 plus t square dz. Sorry. Is sec square z dz. So dz is dt by 1 plus t square, this whole becomes dz. And what's tan sec square x minus tan square is basically tan square minus 1 is nothing pretty. But it's nothing basically. Tan square minus 1, right? It's basically 0 to pi by 2. If you notice the limits from starting, actually I've not been noticing, but yeah, I have track, I guess. So it's simply a reduction formula. Minus s minus 1 minus. Okay, so if we apply reduction formula in cot, we would get this thing. Okay, so I'm sorry that this video was spoiled. Actually, I thought that this would be easy, but it wasn't.